Hey there, everybody. Glad to have you here. We're going to be having speakers, by the way, all throughout today. They're 20 minutes each, and it'll be until 6 o'clock, and then tomorrow again from about 11:10 to 6 o'clock. So we hope you'll come back and join us. But right now, I want you to give a big welcome, if you will, to the stage from Okta. This is Randall Diggs.
What's up, people? How's it going? Cool. Thanks for coming out to check out this short 20-minute talk. Today, as you can see, we're going to be talking about building and deploying static websites using AWS and a little bit of Okta. So a little bit of background about me. I'm a developer at this company called Okta. If you haven't heard of us, we're basically an API service, and what we do is we store user account information. That's really all we do. So we make it easy to support user registration, user login, password reset, multi-factor authentication, sort of all that typical stuff that you do when you're building websites, mobile apps, API services, et cetera. My specialty in particular is web security, so I work on a lot of cryptography and web protocol type problems most of the time. I work primarily in Python, Go, and JavaScript. But through almost all of my career, I've had a really big focus on web performance. And not just in terms of minimizing the amount of time that it takes for your websites and APIs to load, but also reducing the amount of costs you need to spend to host that infrastructure. I actually run an API service called Ipify on my free time. It's one of the largest free API services in the world. It does roughly 45 billion API requests per month, and it costs only $250 a month to power the infrastructure for that, and it's all running on AWS. So anyways, the purpose of this talk is to really explain how you can build and deploy really fast static websites using AWS. That's sort of the goal of what I want you guys to take away from this. But before we do that, I just want to cover how most traditional websites work real fast. So most websites, right, they always have two things in common no matter what type of website you're building. First off, you always have a user no matter what. And secondly, you always have a web server. Even if you have load balancers and a million app servers and proxies and stuff, at the end of the day, you always have web servers and users. And when a user makes a request to your web server to view a page, for example, what's going to happen most of the time is you're going to run some code, which is going to take the request, and then output some static assets, right? Some HTML, CSS, JavaScript, images, video, whatever. And then that data will be sent back to the client in the browser and rendered. So that's Website 101. Now, static websites are exactly what they sound like if you're not already familiar with them. It's just the same exact process, except there's no code involved. So on a static website, all of those assets, the HTML, CSS, all that stuff, is already going to be pre-rendered, sitting on a web server. So as soon as a request comes in to access the data will just be immediately sent back like a file straight to the browser. Makes sense, right? Now, the reason people really like static websites, including me, is that, A, they're super fast. So in the web performance world, there's this metric that we really care about, which is time to first byte. So how long does it take for your website to start sending that response back to a user? And when you're running code on the back end to process a request, you're always going to have some added latency because you're always going to be running a process, executing CPU cycles, requiring memory and stuff like that. It's not the same thing with a static site. Secondarily, they're really easy to deploy. So, AWS has made most of its money and is a huge company today primarily because of the DevOps space, right? AWS makes it really easy to deploy your software someplace in the cloud. And it's a huge multi-billion-dollar industry. And static websites, if you think about the differences in complexity of deploying them, are incredibly simple because all you're really doing at the end of the day is copying a file onto a server someplace. And that's a lot easier, for example, than running VMware, running Docker containers, using Kubernetes, using Puppet, Salt, Chef, Ansible, any of those tools. Static websites can also be really easily globally distributed. So caching those static files at data centers all around the world is really simple when the only thing you need to do is copy a file across the network. They're also a lot easier to maintain and build, which I'm not going to get into, but we can talk about that after if you're interested. And finally, they're really inexpensive. So running a static site is extremely cost effective. I run huge, massive sites that have millions of visitors for less than $5 a month, and that's totally possible when you're building static sites. So next up, what I want to walk you through is actually deploying a real site live on Amazon S3 and sort of making that work. So the first part of this is that you typically need to have a website that's already ready to go. Now, in this case, I actually built something that I'll just show you real quick. So I actually built this little reInvent challenge app. As a matter of fact, it's a single-page static website. If you actually go to the Okta booth after this talk, you can build this thing yourself, and we'll give you a prize if you do. It's really simple. But anyways, this is a static site, right? So we have the website. So the next thing we're going to do is get all of those web assets, the HTML, the CSS, all that stuff, and deploy it to Amazon S3, which is like one of the oldest and best and fucking coolest like services that AWS has. So S3 has been around for a very long time, and it's basically just a place to store files. It's just like a huge folder. And what's great about it is, A, it's really fast, so storing files there is quick, and retrieving them is also quick. B, it's inexpensive, so that's a huge win for me. C, the tooling is really fantastic. So out of all the web services out there for developers, S3 has been around a long time, and there's tons of like proprietary and open source tools for working with S3 and doing these deployment tools. Next, it's really flexible, so there's tons of options in S3. You can choose the default stuff, which is to store things with a very high level of redundancy. You can choose reduced redundancy to save costs. You can archive things to Glacier. There's all sorts of cool rules and stuff you can build. It's also safe. So one of the criticisms that AWS gets a lot of the time is that IAM policies can be sort of complicated, right? So if you're building and deploying real production software, there's a lot of different security policies you can apply. With S3, you really only have a few options, so it's very easy to administrate. And finally, the tooling is really, 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 really good, as I will show you in a second. Now, what you see here is some command line usage. Now, Amazon has this officially maintained AWS CLI tool, which is like fantastic. So if you haven't used it yet, Google AWS CLI, go install it, and then familiarize yourself. But it's really simple. Now, to actually set up and deploy like a live production website, you only need 3 commands to do this. So the first thing we're going to do up top, if you run this on the command line, is we're going to create a new S3 bucket. The MB command stands for make bucket. And what we're doing here is we're actually creating a folder in S3, which is called a bucket. And in our case, it's going to be the name of our website, for example, www.foo.com. The second thing we're going to do with the command line tool is we're going to run the S3 website command. And that's going to take in our bucket. And then we're going to tell Amazon, hey, you know what? Whenever a user visits our bucket, if they don't specify a path, like if they just go to www.foo.com, we want to show them by default the contents of the index.html file. And secondly, if the user tries to access a page that doesn't exist, we want to render the error.html file. So this is how you can handle like 404s and all that sort of stuff. And then finally, to actually deploy your static files into S3 and get it live, what you need to do is you basically need to run the S3 sync command. And the way this works is simple. You're basically telling it, I want to take all the files from my laptop or wherever you are in this folder called public and copy them into the S3 bucket. And what you're going to do here with this ACL option is you're going to tell it all these files should be publicly readable so anyone can view them on the web. And finally, this delete option, what that says is that if I were to delete a file from the public folder and rerun the sync command, that same file should also be deleted from the Amazon S3 bucket. So both the public folder and the S3 bucket should always have the exact same files in them at any given time. Super simple, right? Cool. Now, I'm also just going to pull this up real quick. Whoops. And show you what this looks like in the AWS Management Console. So in my case, I actually created a bucket earlier. And if I click on this bucket called Reinvent Challenge, you will actually see that like here's my files for that static site I showed you earlier. There's an index.html, there's static files, all that stuff has been copied in there. If I actually open this up on the command line, I can run a sync right now, which is going to copy stuff there. For example, I can actually edit my website, and instead of saying hi, I can say demo. I can save that, and I can rerun this S3 command. And now if I go back and refresh this page, it should say demo reinvent. And bam, just like that, we made a change and deployed a static site live. Now, the other thing you should know about this is when you're in the S3 console, there's this properties tab for your bucket. So if you click on this, you'll notice that there's a static website hosting option, which is enabled right now due to that command line thing from earlier. And if you click on this, there's a URL. And this URL is basically your website running on Amazon S3. So that's what I'm sort of showing you the live website is from this URL. Now, the next thing you want to do, so right now we could call it a day. So you could actually go home right now and say, screw it, I'm done. I have my website running live, and you'd be fine. So you could literally build and deploy your website in 3 lines of code. That's awesome. But typically, you want to make things faster, right? I'm guessing that's why you came to like a performance talk, because you want to be faster than just normal shitty websites. So that's where CloudFront comes into play. So CloudFront is Amazon's CDN, and what it allows you to do is basically cache copies of your website in all the different AWS regions and availability zones all around the world. And that way, if a user visits your website and they're located in Sydney, for example, they're going to view a cached copy of your website from the Sydney region. And that is going to make your website much faster to people externally. So the reason you want to do that is because, again, it's super fast. It's also super inexpensive, same as before. The tooling is also great. It's very flexible. There's tons of great options in there. It's reliable, so if CloudFront goes down, you can guarantee that almost the rest of the web is down as well. And finally, the tooling, again, is super, super awesome. Now, the way you set up CloudFront is slightly more complicated than S3, so I'll just walk you through it real quick. So if I go to the Amazon console and switch over to CloudFront, then what you're going to want to do is create what's called a CloudFront distribution. So you can click Create Distribution, click on the web option there, because you want to do this for a website. And the first thing you need to do is tell it what website you want to cache files from. Now, in our case, you actually want to cache it from the S3 website that you already built. So I'm just going to paste the S3 URL in here, and I'm just going to delete all the slashes, because this field should only contain the domain info, none of the HTTP:// stuff. The next thing you want to do is set up an SSL policy. So you should always be running your websites over HTTPS. So I like to enable this option, which basically says, redirect all HTTP traffic to HTTPS. Finally, you want to go, or almost finally, you want to go to the object caching option here, which basically specifies how long CloudFront is going to cache your web pages for. Now, this is where most people screw things up, right? Because when you're caching a site and you want to be super fast, the idea is you always want to serve your website from the cache. You never want it to not be cached. And so what you should do is come in here, copy this maximum TTL value, which is the maximum amount of time CloudFront will allow you to cache a page. Copy the value and override the default and the minimum values with this maximum value. And again, the reason you want to do this is so that your pages will always be cached for the maximum amount of time. And then finally, if you're really obsessed with web performance, you can come down here and click Compress Objects Automatically, Yes. And what this will do is if your static website is just consisting of like HTML pages and images and stuff like that, this will automatically handle things like gzipping your pages to reduce the amount of bandwidth they're taking up, speeding up the page load times and stuff like that. So finally, you can click Create Distribution at the bottom, and you'll be good to go. Now, if I actually go back for a second here, whoops, too far back. I actually already created this distribution earlier, so I'm just going to pull it up. And when you click on the distribution, you'll see that there's a domain name in here. And if you go and you open this up in a browser tab, you'll notice that, bam, now we're actually loading the site from our CloudFront CDN. So this is localized to where we are, which is much cooler. Now, the other thing you might want to notice is this distribution ID. So obviously in CloudFront, you can have a lot of different services. So this is the identifier you're going to need in a moment. Now, what happens if you have your site distributed with CloudFront, but then you want to make a change? So let's say you update your website, you upload it to S3, and then you go view your website and you realize the page didn't update, right? Well, that's because CloudFront is now caching your web pages for like a year. And so you obviously don't want to wait a year for that web page to fall out of the cache before users can see your update. So what you need to do is invalidate your cache. Now, the way you do that on the command line is very simple. So first off, you enable the preview of the CloudFront functionality in the CLI. And then secondarily, you're going to run the CloudFront create invalidation command. And you give it that distribution ID from earlier. And what this is going to do is tell CloudFront in a single command to forget about all the pages on your site and remove them from the cache. And what I like to do is every time I'm building a site and I deploy a new update, I just immediately run this command in a script. And that way, it just wipes the cache, and then a new version of the site can be loaded. Make sense? Cool. Now, if we actually come back to our command line, we can run this as well. And you'll get some nice little output just like this. Bam. And it's in progress. So our invalidation is now in progress. Whoops. In progress. God. There we go. Anyways, back to this. So the one thing you need to know about invalidations is that they take roughly 15 minutes to complete. So one of the trade-offs you need to think about if you want to use CloudFront to make your site very performant is that when you're releasing new updates to the site, there's always going to be a roughly 15 to 20-minute delay embedded in there. Now, I actually really like this because I'm sure a lot of you have seen this famous comic from XKCD. But basically, the only legit excuse that we used to have as developers was that our code was compiling, and that is how we would slack off. So when I'm building all my sites on CloudFront nowadays, the excuse I use to my boss is that, well, my cache is now invalidating, so I have plenty of free time to drink coffee or whatever. So anyways, the next thing you might want to care about And this is where we get into a small bit of a shameless marketing plug for Okta, and I apologize in advance. But basically, it's securing websites. So a lot of people, when they haven't built static websites before, they tend to run into problems getting like security stuff working. So handling user registration, user login, et cetera, is a lot more complicated if you don't have a server-side backend where you can have secured cookies to manage user state. So some of those problems that manifest are it's difficult to handle authentication and authorization logic. Writing the security code on the front end, which should be treated as an untrusted client, can be really complicated. So basically, the best practice is to use the OpenID Connect protocol, and there's all sorts of ways to mess that up. And finally, there's no easy way to store user state. And that's where services like Okta become really useful. So Okta is just this hosted user management service. There's lots of other services like Okta, by the way, so you don't need to use us. But if you are building and deploying static sites, I highly recommend you use some sort of user management service. Open source tools work fine too, because it's going to make your life a lot easier. So anyways, with that out of the way, let's go back to the static site stuff. Now, if you are building and deploying the stuff using an auth service on a static site, the way this works in reality is basically, let's say you build a registration page in your static site. Well, when a user goes to sign up and sends their credentials up to your static site, you're going to have some JavaScript code running. Usually, like you'll install like an Okta SDK or like whatever service you're using, you install their JavaScript SDK, and that is going to pass stuff using OpenID Connect with the authorization code grant type to the backend authorization server, which is hosted by a third party, and that is going to handle like the registering of the user, the password reset, all that typical stuff. So now let's talk about scripting and automating your deployments. So one of the things that I've been doing for a very long time now is whenever I start a new project, the first thing I do, almost universally, unless I'm just hacking around with something for fun, is I set up continuous deployment. Because I don't know about you guys, but I absolutely hate when you build something and then you have to worry about the deployment stuff afterwards. I just like the ability to like push stuff and test it all the time. It makes me feel more comfortable. Now, when you're testing this stuff out, there's tons of services people use, right? There's like Amazon has their own continuous deployment stuff, I believe. Heroku has stuff. There's like a million third-party services like Travis CI and things like that. I personally really enjoy using this free service called Travis CI. I'll actually pull it up for you real quick. So that static website I was showing you a minute ago is actually hooked up to Travis CI for free. So I connect it to my GitHub account, and every time I push my code to GitHub, Travis CI is going to get a new copy of my code, it's going to download it, and it's going to run some scripts that I define to do stuff. And that's a perfect way to handle continuous deployment in general. Now, if you're building a static site, what you might end up having is something like this. So you might end up having a build script that looks something like this. So you might run some code to generate your static site, which is that build script at the top. And then you might literally just run those commands we covered earlier. So sync your files to S3, then invalidate the cache on CloudFront. Those are really the only two steps that you need. And the way that I like to do this in Travis is in my project, I'll expand this a little bit, I have a file called .travis.yaml in the root of my project. And if I open this file up, it's really just a script that tells Travis what commands to run every time I push some code to GitHub. Now, the way that this works is I basically configure Travis so that it's only going to run these commands when I push things to the master branch. So if it's like a production deploy, basically. And what I do is the first thing I do is I tell it to install the AWS CLI tool. So Travis, every time it gets a new copy of my code, will actually install the latest version of the Amazon command line tool. And then it'll run those 3 commands that we covered earlier. So it's going to sync my files into S3. It's going to enable CloudFront with the CLI tool. And finally, it's going to invalidate my distribution from earlier. And what's nice is that that is all you really need to do to build and deploy really fast static websites on Amazon using S3 and CloudFront. So with that, I just want to say thank you for your time. If you have any questions, I'm happy to answer them. Also, if you want to get a free I Find Your Lack of Security Disturbing t-shirt, please come over to the Okta booth. We have tons of them. And yeah, that's all. So thank you guys for your time. I appreciate it.
Thank you, Randall.